An estimate gives your calculator answer a reasonable neighborhood before you press any keys. Consider 19.8 multiplied by 4.9. Round to 20 times 5, so the estimate is 100. The exact calculator value is 97.02. 97.02 is close to 100, so its size is believable. Estimate and exact value answer different questions, but they should tell the same size story. If the display were 9.7 or 970, suspect a misplaced decimal or key. Estimate first, calculate second, and compare before moving on. A stronger estimate can place an answer between a lower and an upper bound. For 48 times 6.2, use 48 times 6 as a lower benchmark. Use 50 times 7 as an easy upper benchmark. The lower benchmark is 288, and the upper benchmark is 350. The exact product must lie between those two values. A calculator gives 297.6. That value sits safely inside the predicted interval. A display of 29.76 would fail the interval test immediately. Bounds are especially useful when decimals make mental calculation awkward. Inverse operations test an answer by undoing the calculation. Suppose 37.4 plus 18.6 equals 56. Treat 56 as the proposed sum. Subtract one addend, 18.6, from the sum. The result is 37.4, the other original addend. Recovering the starting value confirms the addition. Addition and subtraction form an inverse pair. If the recovery misses, recheck signs, decimal placement, and the original entry. An inverse check is independent evidence, not a repetition of the same work. Multiplication can verify a quotient without repeating the division. Divide 144 by 12. The proposed quotient is 12. Multiply the quotient 12 by the divisor 12. The product returns 144. That recovered dividend confirms the quotient. Division and multiplication are inverse operations. For a non-zero remainder, quotient times divisor plus remainder must recover the dividend. Use the operation that rebuilds the original quantity. Unexpected calculator results often come from entering a fraction without protective parentheses. For 12 plus 8 over 5 minus 1, a loose entry may type 12 plus 8 divided by 5 minus 1. That key sequence follows a different structure and produces 12.6. The fraction bar groups the complete numerator and complete denominator. Enter the numerator as open parenthesis 12 plus 8, close parenthesis. Divide by open parenthesis 5 minus 1, close parenthesis. The protected entry gives 20 divided by 4, which equals 5. 5 is the correct value for the printed fraction. The unprotected answer cannot be right because 20 divided by 4 is visibly 5. When the printed notation groups, the calculator entry must group too. A misplaced decimal can preserve digits while destroying magnitude. Suppose 6.4 times 35 is entered and the display is 22.4. The digits look familiar, but the scale is 10 times too small. 6 times 35 is already about 210, so 22 cannot fit. Re-enter 6.4 and confirm the decimal after the 6. Multiply by 35 and press equals once. The corrected display is 224. The estimate near 200 confirms the repair decimal position. Estimate-based scale checks catch errors that digit checking misses. Read the whole magnitude, not just the sequence of digits. When an answer looks wrong, test 4 features before starting over blindly. First, inspect the sign. Should the situation produce positive, negative, or 0? Second, inspect size. Should the result be tens, hundreds, or a value below 1? Third, inspect structure. Did every fraction bar, exponent, and negative value keep its grouping? Fourth, inspect units. Do they match the quantity the question requests? A failed check points to a likely cause instead of merely announcing that something feels wrong. Debug one category at a time: sign, size, structure, then units. A deliberate diagnosis is faster than repeatedly pressing the same keys. Use a 4-part reliability routine whenever a calculator result matters. Estimate the sign and approximate size. Enter the complete mathematical structure. Verify with an inverse operation when possible. Check that the units answer the actual question. Challenge. Evaluate open parenthesis 84 minus 24, close parenthesis, divided by 0.6. The grouped difference is 60, and 60 divided by 0.6 should be larger than 60. The exact result is 100. Multiplying 100 by 0.6 recovers 60. Estimate, structure, inverse, and units turn a display into a defended answer.